All right, everybody. Welcome to the 7.1 video on adding and subtracting polynomials. So chapter 6, we looked at exponential functions, and we did some stuff with properties of exponents. And so now we're going to look at polynomials, which are not going to be linear functions. Okay. And we're going to look at specific types of polynomials. We're also going to look at quadratics as well within this unit. So a couple of things that we're going to be doing in the next couple of weeks. And so that's kind of the idea. So today we're going to talk about finding the degrees of a monomial, how to classify polynomials, and then how to add and subtract polynomials. So that's kind of the idea for today. So let's first start a little bit of a warm up. Again, quick little reminder on some of these properties that we need to be using. So here on this first problem, okay, make sure we distribute and make sure you distribute to everything on the inside of the parenthesis. Okay, and so then when we write this out, we get 5x plus 4 times 2x is 8x. 4 times 7 is 28. And then from here, we can combine like terms. And remember, when we combine like terms, we can combine things that have the same variable and the same exponent. So we can combine these two to make 13x plus 28. And so that becomes our final answer. 13x plus 28. Okay, I can do the same thing on the next one. Okay, I can distribute this negative 6. Just make sure you're bringing that negative with you. And if I write this out, I get 9x minus 6x minus 12 plus 3. Again, I can combine these two to make 3x. I can combine these two to make a minus 9. And I get 3x minus 9. All right, so that was a little warm up. So now let's kind of talk about some of these definitions that we're going to use here. So first one is a monomial. All right, and think about what's inside of the word monomial is the word mono, meaning singular, right? So here, if you kind of follow this along here, binomial meaning 2, trinomial being 3, right? And then instead of kind of keep using different words, we're going to have polynomial, poly meaning many, okay? So a monomial is a single term. It's a single term expression. Which can be a number or a variable or the product of a number and variable. Okay, so for example, 3, right? If I just use the number 3, okay, that's a monomial. 3x, this is also a monomial. This is the product of a number and a variable. And also something like 1/2 a squared is also the product of a number and a variable. So these are all types of monomials. These are all one term. Okay, so now a binomial is just going to be having 2 terms. So 2 terms. Okay, and we separate them usually plus or minus signs. Okay, so then trinomial, we kind of talked about this, 3 terms. Okay, polynomial then is just many terms. Okay, so then we have many. Now, binomials and trinomials are just special types of polynomials. Okay, so a binomial, right? So when you have more than one term, anything that's more than one term is going to be considered a polynomial, right? But a binomial is a special type of polynomial. So I can kind of go back here, say that a binomial is a polynomial with 2 terms. A trinomial is a polynomial with 3 terms. The degree of your polynomial is going to be the greatest degree of all of its terms, which means the greatest exponent. So the leading coefficient is going to be the coefficient of the first term. Coefficient just being the number in front. And when we write polynomials, we want to typically put them in standard form. And so that's when your exponents decrease from right to left. Okay. So for example, we just kind of do a bunch of definitions here. So now, for example, we take a look at these. So here we have a bunch of polynomials. We want to put them in standard form. So the first thing is, why are these polynomials? Because again, we have more than one term. Here's one term, here's another term, here's another term. So 3 terms. So this is a trinomial to be specific. Okay. Now, if we want to put this in standard form, okay, we're going to put the degree. So your degree is going to be the one with the biggest exponent here, so 2. So I'm going to put this term in front, so negative 2y squared. Okay. Now I'm going to put the next exponent, which is this y has a 1. So I'm going to put that next, plus 5y to positive. And then I'm going to put my constant at the end, plus 9. This here is in standard form. So you're just kind of rewriting things to put them in so that your exponents are decreasing from largest to smallest. And so then if you want to figure out the degree, which I'm going to label d, it's just the highest exponent that you have. So here degree equals 2. Your leading coefficient is going to be negative 2. Okay, it's the number in front over here. Same thing on the next one. I'm just going to move some stuff around. Again, biggest exponent goes first, so I'm going to deal with this 4, this power of 4. So negative 4b to the power of 4. Okay, now look at the next smallest one. Well, we have a cube here, cube term, so that's going to go next. It's a positive, so plus 3b cubed. And then we have our last term at the end, plus b squared. Okay. The degree on this one equals 4. Again, largest exponent. Your leading coefficient is negative 4. Okay. Now, a couple of properties that polynomials must have. You must have positive exponents. So that's rule number 1. You got to have positive exponents. You also have to have real number coefficients. Real number coefficients. And you must have 2 or more terms. So on the next page, we're going to kind of go through and look at some of these. I'm going to give you a bunch of examples where we kind of determine if they're polynomials or not. Okay, so moving on to the next page. So here at the top of this page, we want to look at, are these polynomials or are they not? So the first two here, well, let's actually look at this one by one. So the first one here, it's only one term. Okay, we only have one term, so it's not a polynomial. It's a monomial. So put not poly. It's a monomial. Okay, the second one, we actually have 2 issues with it. Okay, first of all, it's a monomial, so it's not a polynomial. Well, let's put that first. Only got one term, and we also have negative exponents. So we're going to kind of go through that checklist that we have on the last page to kind of verify that these are all polynomials. Okay. The third one, it is a polynomial. Okay, so we have more than one term. So we have more than one term. Okay. You have no negative exponents. All the coefficients are real numbers. Okay, so the coefficients on these are 1, 3, and -1. So that's good. Okay. The fourth one here, okay, I could rewrite this. Remember, if you put a variable on the denominator, I could write this as 9m to the negative first power, kind of going back to last chapter. Now we have negative exponents, so not a polynomial. The last one is a polynomial. Okay, we have more than one term. All the exponents are positive, and we have real number coefficients. Okay, so the last thing we're going to be doing in this video is now just combining some polynomials. And to do this, we're just going to combine like terms. So again, for like terms, I'm going to write this down. Like terms, you have to have the same variable, same exponent. So then we can combine them together to simplify this out a little bit. And I'm going to remind you guys, make sure you kind of watch out for your negative signs as you go through this. Okay. So for example, on this first problem here, I have a negative 2x squared and a positive 3x squared. I can combine those to make 1x squared, right? Negative 2 plus 3 is 1, or that's just x squared. Okay. Now keep going through the list. Let's see what else we have. We also have a negative x cubed here and a positive x cubed here. Those are cancel out, so these are just going to go away, right? Negative plus a positive is going to go away. Now I'm going to bring down everything else that I have. Do some different colors. I have a 3x plus 3x and a minus 12. Bring those down. Okay. Take a look again before you kind of submit your answer, right? Can I combine anything else? This x squared and the 3x I can't combine because we have different exponents. So this right here is simplified, and that's my answer. Okay. Take a look at the next one. Again, if I look here, this first time I got 4x cubed, and I'm adding another x cubed to make a total of 5x cubed. Okay. Now take a look at the next term. We have a positive 2x squared. But here we're minusing 3x squared. So again, just keep track of your positive and negatives to make a negative x squared. Okay. Next, I have a minus 4, and that doesn't really combine anything over here, so I'm just going to bring it down, minus 4. And then I also have a plus x. I'm going to bring all those down. Now, we're almost done. Okay. The only thing that I want to do is put this into standard form. Okay. And so the only thing that's going to really matter here is I'm going to switch the position of these two guys right here. Because I want all my variables first, and I want my constant at the end. So if I rewrite this, my final answer is going to be 5x cubed minus x squared plus x minus 4. And this is my final answer. Okay. Now this is in standard form. Okay. I have my biggest exponent first, going all the way down to the constant. And I have all, this is a polynomial because we have multiple terms and we have all real number coefficients. So this is now a polynomial in standard form. Okay. On the next one, here again, be careful. You gotta distribute this negative sign to everything. So now when I start combining these, I have a 2c cubed minus a 3c cubed, right? When you minus that, you get a minus 3c cubed. And so when you combine those together, you get negative, sorry, not cubed, squared, negative c squared. Okay, this is all squares. Okay, do the same thing on the next one. I have a minus sign and another minus sign to make a plus 4c. And if I do the last, I have a minus sign distributed to a plus 1, so then I have a -8 minus 1, which is -9. And if it's easier for you, you can just rewrite the problem if you have to, right? You could rewrite this as 2c squared minus 8 minus 3c squared plus 4c minus 1, right? If I distribute that negative sign in, I get a minus 3c squared plus 4c minus 1. And now we're just combining these terms here. It's in a box. So combine the boxes and the underlines. Okay. And you get the answer that I have there in the colors. Okay, so again, just keeping track of the positive and negatives. Okay, moving on, second to last question here. So we have 5y squared plus 2y minus 4 minus a negative y squared plus 4y minus 3. So again, distribute this negative sign in and change all the signs in the second expression there, second polynomial. So we have a 5y squared plus another y squared, right? These two negatives are going to cancel, so I end up with 6y squared. Okay, my next one, I have a 2y minus a 4y, so I'm going to get negative 2y. Okay, so I have 2y, and I'm distributing this negative, so that's going to make this positive 4y negative. So I have 2y minus 4y, and I have the negative 2y. And on the last one, we have a minus 4 plus 3, which is a minus 1, right? We have this negative and negative turn into a positive, so we have negative 4 plus 3, which is negative 1. So this right here is my simplified polynomial. Okay, last question here. A penny is thrown straight down from a height of 200 feet. At the height, a paintbrush is dropped from a height of 100 feet. The polynomials represent the heights and feet of the objects after t seconds. Write a polynomial that represents the distance between the penny after the paintbrush, and the paintbrush after t seconds. Okay. So here we've been given these two polynomials, and we're dropping a penny and a paintbrush, and we want to try to find the difference between the two. Okay, so I can write this as negative 16t squared minus 40t plus 200 minus, and then in parentheses, negative 16t squared plus 100. Right? We want to find the difference between the two. Difference meaning subtraction. Okay. Once I distribute this negative sign through, and I simplify down, I get my difference, my polynomial is going to be equal to negative 40t plus 100, or minus 100, or plus 100. Yep. Plus 100. Plus 100. Okay. So again, this negative and this negative turn into a positive. So you have a negative 16t squared and a positive 16t squared. Those are going to cancel. You still have this negative 40t, so I just brought that down. And then you have 200 minus 100, which is just 100. So this right here. So now what do these represent? Well, this 100 here represents the initial difference between the heights, which makes sense because the first person drops at 100 feet, second person drops at 200 feet. So this difference here is just 100 feet. So that's where that 100 comes from. And that 42 kind of represents the rate of change. So that's kind of what this problem is looking at. We're just looking at the difference between those two things. So that's it for this video, guys. As always, if you have questions, let us know. But again, in this video, we looked at what is a polynomial. Again, polynomial of multiple terms, can have negative exponents, must have real number coefficients. We talked about combining like terms. Again, same variable, same exponent. Make sure you're watching out for negatives and simplifying down. So that's it for this video. If you have questions, let us know. But if not, have a great rest of the day.